Mm-hmm. Yep. Tonight, let's solve a hard problem. Your task is to determine for each queries whether there is a path between J, Pj, and Qj such that each edge on the path has a distance strictly less than limit j. Return Boolean answer where answer length equal to queries length and the j's value of answer is true if there is a path for queries j is true and false otherwise. The above figure shows a given path. Given a graph, there are two overlapping edges between 0 and 1, distance 2 and 16. For the first query between 0 and 1, there is no path where each distance is less than 2. 0 and 2. Hmm. Okay. 0, 4, 14, 1, 4, 13. All right. So easy, right? So we are going to sort all the queries by the limit and we're going to move all the edges that is less than the limit into the graph. And in the graph, we maintain a union find data structure. And the nodes in the same union find group are connected, right? So that's how we're going to solve this. And the time complexity is n log n to sort the limit, to sort all the queries. And cool. So shall we? The 13 is first, so we put in this edge, this edge, this edge. And these four dots are connected, and 4 is not connected with 1. So we have to put the false here. And with the limit 14, we have all the edges in the graph. So all of them are connected. So we return true. All right. Let's do it. So yes. So first, we're going to have a, so the, let's see, okay, so we have n here. So we are going to have a union find array, and the size of this array is equal to n array. And initially they're in their own group. So we're going to have union get and we are going to have union merge x and y. X group, Y group, and if X does not equal to Y group, then we merge. And the way we merge is that union X group equals Y group. Right. And excuse me. And we are going to have QS sorted by limit. How can we sort this guy? So we need define a custom sort function. So kind of forgot how to do that. I think it's here, right? Custom sort. Awesome. QS kind want to define the sort function outside. Can we do that? Cool. Nice. So the smallest Q limit is in the front. Cool. CMP. And sorted edge accessible. Let's see. Let's see if it does work. Okay. Speed up. Two, four, eight. It's already sorted. Okay, it looks great. Right. Yep, it looks great. So that's the first step. The second step is to iterate through all the Actually, wait a second. In the answer, we are going to have n. So for to I QS, we are going to push the index in push the index into the query. Right. And then we're going to iterate each of the queries. And here is our pointer of edge. While j is smaller than ESS and ESJ limit is smaller QSI2. Merge these two guys. So edge J merge these two guys because we are going to put the edge into and after we put all the edge into the graph, we are going to check answer QSI 0, 1, 2, 3. And 3 equals 2. True or false? Union get QSI 0. We check if these two nodes are in the same group. And we return answer. Yep. And we comment this out for now. Let's see. Don't panic, right? Let's output the current QS. Current Q. Q E Q S I 0 left right limit and index. Okay. And here merge yes J yes J yes, J, J. Let's see what is going on. First of all, let's sort it first. Make it easier for us. So the first query is limit is 2, and we are going to merge 1 and 2, right? 2 and 0, 0 and 1. Yeah, that's good, right? So Q x is 0. Is 0 and 1 connected? Yes, it is connected. So strictly less than, strictly less than limit. Wait, wait, wait. Right. That's more like it. Okay, let's use example test cases. Cool, pretty good, pretty good, pretty good, pretty good. Hmm. Yep, I guess that's it. I kind of like this hard problem is not that so hard. So, shall we get a new one? Yeah, let's do it. Let's do a new one. Longest string chain. Hey, how many problems did I solve? 200. You are given an array of words where each word consists of lower English letters. Word A is the predecessor of word B. If and only if we can insert exactly one letter anywhere word A without changing the order of other characters to make it equal to word B. For example, ABC is predecessor of ABAC. Well, CBA is not a predecessor of BCA, BCAD. A word chain is a sequence of words with k bigger than 1, where word 1 is a predecessor of word 2, etc., and so on. A single word is trivially a word chain with k equals to 1. Return the length of the longest possible word chain with the words chosen from the given list of words. So, increase subsequence, right? Interesting. So if A is a predecessor of B, then and B is predecessor of C, that means the graph will look like this. Have a few layers, and the first layer only has one character, and this character can move into the second layer, and the second layer can move into the third layer. Right? It's like a topology sort. Interesting. Okay. How many words do we have? Only 1,000 words. Cool. So, let's do it. Should be fairly easy. First, we are going to break those words into sets according to the word's length. And then we are going to solve from left to right. And each time we're going to calculate if we reach to current word, what is the longest chain we can have, right? And we can promote this answer to the next layer by adding 1 to it, right? Cool. So, shall we begin? Let's begin. String. We use this to record the final answer. And here we're going to have layer. Check each word and insert it into the layer. And then for each layer, current length equals to first current set current set is second. Don't want to deep copy it. Um, Pick a word from the current set. And also pick another word from the next layer. If check distance check if there is a predecessor. So how to check? Hmm, X if xi equals to yi plus diff, then that's okay. If not, then diff check, if check, PQ. Return F Q equals to F Q 1 plus F Q. Right. And we update otherwise. Returns. Oh yes, pretty good. Smooth, smooth as silk. Okay, I'll take a break. Thank you for watching.